Lesson 4.5, we're going to learn about graphs of sine and cosine functions. Now these are transverse waves. Transverse waves are like electromagnetic radiation, light waves, all those types, as opposed to longitudinal waves, which are sound waves. So these are all transverse. One revolution, we looked at a unit circle, and the unit circle has 2 pi revolutions. So we're going to look at one revolution, which is the same as one cycle, which is the same as one period, which is the same as 2 pi radians. And the symbol for period is capital T. And so when we're talking about one period, we've got a sine wave graph here. We're just talking about starting out at 0, 0, and following that's one period. Period is 2 pi radians. Now the domain of sine and cosine are all real numbers unless you restrict the domain, which we'll talk about later. And the range is from a -1 to 1 unless the amplitude is changed. So that's typically what we're looking at for a regular sine wave. And again, one revolution will start at 0, 0 and go back to 0, 0. A couple of points to notice. Well, there's 5 that I'm going to highlight, and I'll do that. I guess I'll do it in green. So this point, this point, this point, this one, and this one. So 3 of them are x-intercepts, and the other 2 are the amplitude. And the amplitude, which is shown right here, it's from the axis, or this is called kind of the neutral, or the, I guess the neutral line would be good. But the amplitude could also be right here. Amplitude is always going to be a positive number, so we don't have negative amplitudes. But it's just the distance between the x-axis, in this case, and the peak. And let's see, what else? So we have 2 amplitude points. We have 3 points where it crosses the x-axis. And so when we start sketching these, I'll talk about the importance of that. So the next graph down is the cosine. Notice the cosine starts out at 0, 1 and ends up at 2 pi and 1. Well, again, 2 pi is the same as 0. That's one. They're both coterminal points. And so when we're sketching the cosine curves, it starts at 0, 0, and it goes down, and then it goes up. So that is one cycle, one period. It's also the wavelength. So the wavelength is the same as a period. Okay, the important points on the cosine curve, again, are the intercepts and the amplitudes. One more thing I need to mention is notice the x-axis is labeled in dimensions of pi. So we don't have numbers, so we're starting off pi over 2. There's pi over 2, pi, 3 pi over 2, and then 2 pi. And it goes on 5 pi over 2, 3 pi, etc., etc. So you'll want to label the x-axis in terms of radians. Okay, now let's go to, before we look at more stretching and shrinking of these curves, let's look at the general equation for sine and cosine functions. So it's y is equal to v plus a sine of bx minus c. So this v is the vertical shift. And what we do, we shift it from the neutral point, which is right here. We're either going to shift it up or shift it down depending on what the value of v is. Most of the time it's going to be 0, and so we won't even have it. Okay, the A, this is the amplitude. In the above graphs, the amplitude is 1, so we didn't even list it. B is the horizontal stretch, or could be the horizontal shift. So this is just the horizontal shift. Could be stretch or it could be a shrink. The C is the horizontal phase shift. Horizontal phase shift. And also I have a BX. X takes the place of theta. And so that's the angle. Okay, so let's look at how this works with vertical stretching and shrinking using the formula. We're going to forget about the vertical shift and the horizontal shift. So we're going to say this is the formula: y is equal to a sine x. And we'll see what happens if we have different amplitudes. So looking at these three curves, the first one we'll look at the one we had before, y is equal to sine x. So you know in here a is equal to 1. And the thing you notice about these three curves is they all have the same intercepts, which means they have the same period. But what changes is the amplitude. If you look at the blue curve, you see the amplitude right here is 2. And at this point, it's a -2. So this is the value of A, tells you what the amplitude is. If you look at the green curve, the amplitude is 1/2. So that's where the 1/2 comes in. So vertical stretching and shrinking, what that means is you are stretching it away from the x-axis in the case of A greater than 1, or you're shrinking it towards the x-axis when A is less than 1. Okay, so that's it for vertical stretching and shrinking. Let's look at the horizontal stretching and shrinking. So here we have to identify the period. We said earlier that the period is 2 pi. Well, when stretching and shrinking come into play, B is not always 1. And so we have to say that the period, which is T, is 2 pi over B. Now, it may be that B is 1 in the previous cases, but it's not always going to be 1. So let's look at our three curves. So the red curve, this is our normal one, y is equal to sine x. You notice that A in this case is 1. And B is whatever is in front of x. So this is, I could have written this, y is equal to sine of 1x. So it's the sine of bx. In this case, x is 1, and that makes our period 2 pi, which is from here to here. That's our period. T is equal to 2 pi for the red curve. All right, let's look at the blue curve. We have y is equal to sine of 1/2 x. So 1/2 is our b. Now notice that if b is between 0 and 1, then we have a horizontal stretching going on. So here b is equal to 1/2. And so if we are calculating our period, t is equal to 2 pi over b, which is 2 pi over 1/2, which is 4 pi. And so if you look at the curve, makes one cycle here, and from here to here, this is a period of 4 pi. Let's look at the purple one. This is getting kind of messy, but oh well. So let's look at the purple one. Y is equal to sine of 2x. Well, b is equal to 2 in this case, and this means we have a horizontal shrink. And so the period for the purple one, t is equal to 2 pi over b, which is 2 pi over 2. The 2's cancel, and the period is equal to pi. So on the blue one right here, from here to here, this period is just pi. So, thing to remember, if b is a fraction, then you have the opposite effect. You're stretching the curve out. If b is greater than 1, then you are shrinking it. Okay, let's look at some translations. We'll do a couple of examples here. We're going to b, which is 2 pi. Here, this is a period of 4 pi. Let's look. And the period is equal to pi. So on the blue one right here, from here to here, this period is just pi. So, thing to remember, if b is a fraction, then you have the opposite effect. You're stretching the curve out. If b is greater than 1, then you are shrinking it. Okay, let's look at some translations. We'll do a couple of examples here. We're going to use the form y is equal to a sine of bx minus c. Remember, a is the amplitude, b is the horizontal shift, c is the horizontal phase shift. So when we first get a problem, like this one, sketch y is equal to 2 sine x minus pi over 2. We want to identify a, b, and c. So a, the amplitude in this case, is 2. B is equal to 1. That's the coefficient in front of x. And c is equal to pi over 2. So draw your coordinate system, and we're going to label the amplitude. So it's 2 units. So here's 1, 2. Now, here's what's really important. When you're doing the, well, first we have to look at what the period is. Forgot to do that. So t is equal to 2 pi over b, which is 2 pi. So the period tells you what you're labeling the x-axis as. And you want to start off by having 4 equal size intervals. So I'm just going to do that. And the fourth one being 2 pi. So put pi in here. You don't have to put the pi over 2 and 3 pi over 2 if you don't want. Okay, now we're ready to sketch this. Okay, remember this is a sine curve, so it starts out at 0, 0. And the way we sketch these is we draw in those 5 points that I talked about earlier. So it's going to start here. And there's the second point. Third point is here. Fourth point here. Fifth point here. Now you got to do your best to kind of sketch it and not make it look like real pointy top and bottom. So the way I kind of sketch it is, for me, it's easiest just to kind of dot it, because I don't know, for some reason it seems like it's easier just to dot it rather than a solid line. Then you can go in if you want to and fill it out a little bit better. So I'm gonna, they don't have to be perfect, but the better off it is, it's just gonna look pretty, and you want things to look pretty. So here we have, oh, but what didn't I do? Now this phase shift, so I'm gonna just erase everything that I previously did. Okay, let me do some erasing. Okay, so those, we'll go back to where the dots were, but I forgot about the phase shift. Whoops, so this is a negative pi over 2. Since it's negative, you're going to want to start at a positive pi over 2. So I'm going to redo that now. Okay, so normally we would start here with a sign, but we're shifting it to the right, pi over 2. So here's where our first beginning point is. And now I'm going to fill in the other dots right here. So now we shifted it. I'm going to do my dotted line again. Okay, so now I can go and fill it in a little bit better if I want to. Okay, so here is one period of y is equal to 2 sine of x minus pi over 2. Now, if we wanted to draw more than one period, we could just continue the graph here, and then we could go up to this point here. But usually, you only need to draw one period, maybe a little bit on either end of one period would help. So, the thing I didn't mention here, let me mention it now. So the interval is going to be, it's going to start at pi over 2 to 5, this would be 5 pi over 2. So this is something that you can do before you sketch it if you want. And I'll show you how to find the interval. So the interval is pi over 2 to 5 pi over 2, and use brackets because they can be equal to these. So how would we go about finding this out if we didn't know? Well, look at, let me write the original equation again. Y is equal to 2 sine x minus pi over 2. And we already said, or we found out, that the period is 2 pi. So if we're trying to find the interval, we want to set x minus pi over 2. We want to make that equal to 0 and solve it for x, and that gives us x equals pi over 2. That's your beginning part. Then we want to set x minus pi over 2. So this is just what we're doing is setting whatever is in the parentheses here. We're going to set this equal to the period, 2 pi, and then solve for x again. So x is equal to 5 pi over 2. So that's another way of getting your interval. You can do that before you graph it, or if you just look at it and say, well, I know the phase shift is a negative pi over 2, so I'm going to go to the right pi over 2, and that's where I'm going to start my curve. Now you can do that also. Okay, here's another example. We want to sketch y is equal to negative 1/2 sine of pi x plus pi. Okay, so the negative, this means it's going to be inverted. In other words, it's a sine curve, so instead of starting going up, we're going to start going down. The 1/2, this is A, the amplitude. B is equal to pi. The phase shift, this is pi, that's C. And it's positive, so it means we're going to move it, shift it left. And so now we have to find the period. So T is equal to 2 pi over B. B is pi, so the pi's canceled, so the period is 2. So when you have some form of pi, some fraction of pi, could be pi over 2 or whatever, as B, that's going to change your x-axis labeling. You're not labeling it as multiples of pi, you're going to be labeling it just with the numbers. So now, let's go ahead and find what our interval is going to be, because the period is 2. So we're going to say pi x plus pi, set that equal to 0, and that gives x is equal to a negative 1. Then we have pi x plus pi, and we set that equal to 2, and that gives x is equal to 1. So this gives our interval, and our interval is negative 1 to 1. So we know our starting and ending points. And now let's go ahead and do our coordinate system. So let me start it a little bit closer. So here, do that. Now remember, you want to have 4 intervals in the period. So, and you want these intervals to be the same size. So let's do 1, 1, 2, and we can go on the other side, 1, 2. So I don't know, maybe I should have made it bigger, made a bigger graph, oh well. And the amplitude is 1/2. Let's just call this 1/2. So here's negative 1/2. So this is a sine curve. Normally it's going to start in the positive direction, but it's inverted, and it's going to start at a negative 1. So our starting point is going to be right here, and it's going to go down to here, and then here, and then here, and here. So it's good to know where the beginning and ending. Oh, I did that wrong. Well, let me back up on that. Okay, let me start over. So our period is 2, and so we're starting right here, and we're going down. And so it's going to be this point here, this point here, and then here. So our overall period is 2. And so now I'm going to draw this just by dotting it. Okay, so I probably could have made this graph a lot bigger, but here's what it looks like. Now you can adjust either the x-axis or y-axis to however tall or long you want it. Just depends on what you want the graph to look like. But the important thing is this, on this particular one, period 2 has to have 4 intervals. So when we start here, there's 1, 2, 3, 4. So it goes 1, 2, 3, 4. 4 intervals in this period. Each interval is 1/2 in length. Okay, so that gives you an idea how to do these. And one other thing, we didn't have a V, but if, let's say in this case we had we said that V was equal to 1. What you would do is just shift the entire curve up to a new line, X line, and I would just dot it in like that, and then start from that point. That tells you that this is the original y equals 0 here, and this is a y equals 1 dotted line, so that kind of indicates that you have a vertical shift. Okay, that's it for 4.5.